Example 2 talks about writing a quotient equation. So as soon as they say quotient, you know that's division, and you remember that we're going to have to be looking out for anything on the denominator that's going to make the denominator 0, because that's not a possibility. So as soon as they say quotient, you have to kind of keep in your mind that whole asymptotes, non-permissible values kind of thing might come up. Meanwhile, we start out easy. It just asks us for the domain and range of the first two functions that they give us. So I know that f of x equals square root x has a domain of x is got to be a positive number because you're taking the square root of it. And y is going to be a positive number as well because it is the square root, so that's pretty much self-explanatory. If you get confused on that one, you can always use your graphing calculator and just plug that in, y equals square root x, and you'll get a visual picture of it. On to the other one. It's a little bit more complicated, but not much. I mean, we've got x minus 3 squared, so you know that that's just a quadratic function that's been moved 3 spaces that way. You can plug it into your calculator and have a look if you want to, but for the most part, it's just like all the other quadratic equations we've been dealing with. So we know that the domain is x is in the realm of all real numbers because it's just that big, nice parabolic swoop that goes on forever this way. The range is going to be limited by where the vertex is, and in this case, it hasn't been moved. There's no number here, so it hasn't been moved up or down, which means the range is the same. So it's just going to be y is greater than or equal to 0 because it's still sitting on the axis. So we've got those out of the way. The next thing that it asks us to do is make a new function where q of x is equal to, just make a line there, f of x over g of x. So now we're going to just write in, so q of x equals, make our line, and we're just going to write in this part of the formula where f of x was, and this part of the formula where g of x was, so becomes x minus 3 squared. Now that's our new formula. We can plug that into a graphing calculator, and that's probably the easiest way for us to get our new domain and range. So, got my little graphing calculator, turn it on, it's always a good way to start. And then when I plug this into my graphing calculator, always remember that you need to make sure your denominator stays together. So this one's already got brackets in it, should work fine. If it didn't have brackets, I'd have to put them there. So I'm going to go second function root. Whoops, that's the wrong button. X, page over, divided by bracket x minus 3 close bracket squared. Graph it, and as you can see, I've got kind of a funky graph going on here. And it looks like I've got an asymptote at x equals 3, which would make sense because if I look at the formula, I cannot have, so I could even write x cannot equal 3 because 3 minus 3 would be 0. So what I end up doing when I look at my graph is determining that, oh, that's funny, that x, well, let's just do a sketch here. That might be easier to see. So I'm going to sketch the graph just loosely. Goes up like that and goes like that. So it's not touching the x-axis. I could check to see if it's actually touching the x-axis right here by going into my table of values or by using the trace function or my second function calcs. But I'm just going to go to second function table, and it gives me a value for 0 and 0. So that means that this line does actually start there. So for my domain for this function, it starts at 0. So x is greater than or equal to 0, but you have to remember that x cannot equal 3. So you've got these two little distinct portions of what the domain is. Remember that the domain is just all possible values for x. So if there are any stipulations on what x can be or any limits, you have to include those in your domain. Now for range, I'm going to look at the graph again. Obviously for range, it just keeps going up. So that isn't going to be a problem, but it doesn't go down past 0. So my range for this one is going to be y is greater than or equal to 0. So the easiest way to get the domain and range of a new function is simply to put it into your calculator, look at the graph, read the points, and determine it from there.